where all of you guys come in. This is what we've developed here with High Mobility, is this workspace. And in this workspace, you can create your own app that combines the High Mobility API with IOTA. And there's some really interesting stuff that can be done with this. And you can imagine, just from what you was saying, how you can combine the API, all of the various things you can control in the car, and how that data might be useful to put on the Tango. Some of the examples are usage-based insurance. That's a big deal. Lots of companies are looking into that sort of thing. And this type of solution, combining the Tango and this API access, is a great way to do that. But let's start a little smaller here. We're not going to do usage-based insurance for this. We're going to start off, we created a little blueprint here. And it's all about paying for electric vehicle charging with IOTA tokens. And Jan, there in the back, he's the one who wrote the code, so you can ask him questions later. But so in this blueprint, really, this is just a go through these steps, and you can then try and build your own. This is kind of like a Hello World program. You can use these code samples and ideas to build your own and then expand on it. So first thing to note, this is sample code for a really basic Node.js app. And we really strongly encourage you to please go through, if you're not familiar with IOTA or not familiar with High Mobility, please make sure you go through the IOTA for Developers site and these downloads and tutorials. They're really, really extensive and really help you with your programming. But the question is, why would you create one of these charging apps? How would this be useful? And in the world of EV charging, compatibility has been an issue. And getting all of these things to communicate with each other and payment systems, it's still very problematic. But we've come up with an app where it really simplifies that. And you have your own wallet that will connect with the charger and then pay for charging with IOTA tokens. So here, we've just got a few code snippets here of what are in the app. Can I zoom in a little here? Can people read that? Doesn't matter.
Reading would be difficult anyway.
Yeah. Okay, that's a little better. So this is just some really the beginning steps of what's in this app. There's the really simple imports. This is an important point here. This converter is necessary because IOTA uses trinary and not binary for various reasons that the technical people can explain better than I can. And here's really, really simple here. And then you've only got two classes in the program. You've got your vehicle and your charge point. So that's all there is. It's super simple. And then here is your function where you are sending the payment transaction for the charging. So you just add your seed, the amount, and the recipient's address, and you've got your charging paid for. So, okay, so probably a little more difficult than that. But this is the draft website. As Kevin said, it's going to be ready soon. This is kind of a sneak preview. We hope to have it done in a couple weeks. And we will have this online where you're able to go to the GitHub repository, check out the code yourself, work with it yourself. And one of the really cool parts of this is that within the High Mobility website, you can set up teams and work on these apps together. Or you can do it by yourself. But then once your app is done, you can submit it and have it reviewed by car makers and OEMs. First it'll go through an internal review process, but then it'll actually be submitted to the OEM. And we really, really strongly encourage you to do this. Be creative with these apps. Mobility really is the future. I mean, that's why we're here at Bribery. And so this is one way to really get started with this. And We encourage you to join our community as well. We've got, on the IOTA side, most of our dev community works on Discord, so please join Discord. There's an invite here. High Mobility also has a Slack channel where you can discuss things. We will, in a week or so, have a specific channel on Discord for these high mobility apps where you can talk with people about it. And we're going to be doing things like webinars where we talk about additional how to work with this code if people have questions. We also really would like any community-developed apps, if you could submit them to us, and if the quality is good and you want to show it off, we can put it up as a blueprint on here. That would be a really nice way for everyone to get involved and see what can be done. And then finally, if you're interested in some of these things in more detail, this is an additional project that was done by Elad in the Netherlands. It's a full charging station that utilizes IOTA. It's actually, they built a charging station and modified a mini Tesla to use IOTA and connect and do charging there. And it's automatic. You plug it in, it does all the negotiation of the payments and charges it, and then you just unplug it and go. So there's lots of really interesting things out there. We really encourage you to please join us with this, you're the community, and we wouldn't exist without you. So. Questions?
One question about the demo code. I saw that was min weight magnitude set to 9. And the mainnet has 14 right now. Yeah. So my question is, will it be lowered in the future because of the snapshots?
Yeah, it's a testnet. These are using testnet tokens. This is not real IOTA. They're being exchanged on the mainnet. So we're setting it up where you can get your own seed and your own set of tokens on the testnet to use with these apps.
Okay.
The faucet should be running again very soon.
Thank you.
Anything else? No? Okay. Thank you very much. So, where's the next person?
You were hoping for a mainnet faucet, right?
I had a lot of examples for the API, and everywhere min-weight magnitude is set to 18 in the examples. And every time you copy the API sample, you run into the problem that it computes forever for proof of work. So maybe the examples should use mainnet min-weight magnitude everywhere.
I think it's very good feedback, right?
Yeah.
It's very good. No, it's really cool, and maybe we should work with feedback. I mean, is there any other feedback? Is there anyone who would try it out? I think that's cool idea.
Yeah, I tried it a few months ago, and having a transaction, I think, was quite fun to see. Is it still like that?
No.
That's good.
Yeah. Cool. I mean, it's actually a tool for everyone to try it out. The mobility app to use simulated car data, because sometimes it's maybe a little bit frustrating if you want to build stuff and you don't have access to a car. And then I think it's really motivating to know that once you submit the app, you can actually reach OEMs. And they're desperately looking for good ideas for developers. I mean, I've been with Daimler for many, many years, and I know that they have really, maybe they try to hire some talent, but most of them are focused on hardware development. So they're really looking for good people, good ideas, and they have the money as a niche incentive to look into. Cool. So
just one question: is there any API for representing the battery of an electric vehicle?
Yeah.
Anything?
Yeah, there is it's quite a lot of electrical APIs. I mean, a lot of electrical cars, typically right now, that's one key place where car companies experiment a bit and are more open to having APIs, because people, if you buy an electric car, they're also a bit more forgiving if everything doesn't work.
I mean, in your virtual car.
Yeah.
Do you have that in there?
Yeah, sure. I mean, in the virtual cars, we have around almost 300 different data points that we have standardized. But obviously, the first or the production cars you can reach, they don't have that much data points yet. But with pilots, you can still submit it, and these can be considered for special projects.
At the end of the meetup, I can, for people who are interested, I can show you what's in the API, and also maybe throw up there the live picture of the Tangle as the transactions are being approved with some really interesting things going on there, stuff like that. So I'll put that up there at the end of the meeting.
Maybe just one anecdote. I was just at another conference 2 weeks ago, and I heard from some hackers, I would say, that they created a Tesla. Actually, he used his own Tesla, and they drove the car with their brain waves. So they made it, and they really just they had to think of two different things, to the left and right, auto steering, and they could do that. So probably it's not a good idea for a Tangle because everybody can see your thoughts, but
we can encrypt it with the man channels.
The limit is the sky.
Did you drive a straight line?
Sorry?
Was it a curvy path?
I didn't ask.
Thanks.
So, a question to the room. While you're listening to the third presentation, I would like to take some pictures, and share them with Elisa. But I need to know if anybody objects. Yes, exactly. If I want to take a crowd picture, and you will be visible. Is there anybody who would object to me walking around and taking a couple of pictures and sharing them with Elisa? Is that okay? Yeah, everybody? Otherwise, okay, super, thank you. And then I'm going to actually move this banner a little bit backwards so I can get the picture. Okay?
Hello. A couple of colleagues of mine have developed this IOTA car wallet proof of concept, and they wanted to come here and present it, and they couldn't, so I'm the replacement. Plan B, so to speak. Yeah. So the cool side is these are not my slides, mostly of them. So if there's a mistake, you can just point it out to people. It's convenient. I'm this guy. I'm Sven. I'm a computational linguist actually, so I try to make computers talk. But I've been involved in IOTA for like 2 years now. And if everything turns out like I want it to, which probably is not going to happen, but we will see, then I'll even base my PhD on IOTA, which is about building Skynet on it, basically. I also happen to have ended up at Exasec, which is a company I'll just talk to in a second. And I work in research and consultancy, so it's focused on distributed ledger technology and especially IOTA, which is why I'm here. Yeah, so Exasec, some of you might know the company. It's relatively known in the community, I suppose, because we did the Trinity wallet audits in the first, I don't know, half a year ago or something, that you talked about. It's a relatively small company that it's a security focused company. We do like industrial IT security, we're in healthcare and automotive, obviously, and in toying around with ID stuff. And lately we've been starting a lot of new cool projects with IOTA. We got 6 or 7 projects that I know of, at least centered around IOTA now, and this is one of them. So, what happened around, I don't know, a couple of years ago, was a research project. It's called CEDAFA, which stands for Security und Datenschutz fürs Fahrzeug, or something like this. So, what CEDAFA basically tried to do, it was by Fraunhofer and Exasec and a lot of other players, and it's public included, was answer the research question that given a car that's more or less autonomous, and you want to charge it, and also given all the entities on the other side of the charging, like the charge point itself, the operator who does the charge point, the clearinghouse, the energy supplier, all these other entities, how can we make sure that as soon as we charge the car, these entities only get exactly the data that they are supposed to have, and not more? How can we make it secure and private? And how can we make them not track you more than they have to, obviously, for billing reasons. And Cedava basically concluded in this target architecture, which you can forget as soon as I put the slide away. The point being, it used certificates for securing stuff. And they concluded that, well, technically the solution, the architecture works, but it doesn't scale at all, because for certificates you need to have certificate issuers, and if you have a lot of certificates, and you have a lot of certificate issuers, and no interoperability at all, bad scalability, and it wasn't even GDPR compliant. But they made an ISO style out of it, so that's nice. So XSEC kind of saw the oh yeah, and if you view this in an industry 4.0 context, which is like the Internet of Things basically, then you get all the other challenges as well, which come with the Internet of Things, which is billions and billions and billions of transactions, and you need to handle those, and you have to have like high interoperability, because if I charge my Tesla at the Daimler station and then it doesn't work, then that sucks. And then you need data integrity for all these transactions, and you need low resource consumption and all that stuff. So that didn't work at all. And XSX saw the opportunity for basically creating this proof of concept car wallet based on IOTA, because IOTA is awesome and it works. And the idea is basically that if you have a car wallet that's secure, then it enables all these use cases that you can do if you have a car that's a complete autonomous economic agent, basically. So you can make your car pay the road, for example, per meter if it's a toll road, or you can have a car sharing problem, or you can make your car pay the gas station or the electricity station, or however you want to call it. So that's nice. So the idea was that basically, when you register your car, when you buy it initially, or when you buy it from someone else, then you have a registration office, obviously, because you have to have some legal side as well. And the registration office will give your car a unique ID and post that ID to the tanker as well. And the car also has a seat implemented in this wallet to pay stuff. So now, as soon as you go to some point of sale, whatever that point of sale is, for example, the gas station or the repair shop or whatever, then what will happen is that the point of sale will ask your car, please authenticate yourself. The car then provides the ID given to it by the registration office, and the point of sale can now cross-verify that with the tanker, because the ID is stored on the tanker as well. So that was the basic idea, and if then these two IDs match, are the same, then the vehicle is authenticated, and then in the next step, the car can just pay with a normal IOTA transaction, which it's like a normal IOTA transaction. For those of you who don't know it, some service will happen, and then the point of sale sends the amount and the address to send that amount to the car, which then publishes a transaction to the tango, and as soon as the transaction is confirmed, then the car can move on. So that's the basic idea. This is the proof of concept that was implemented. It works already. I think the CEO of XSEC, Sebastian, tweeted that this is going to be demonstrated before Christmas in some grand demonstration, I don't know, which you can look forward to. The cool thing is that it also has a hardware side. This is one of the other projects we are doing right now, but trying to do, obviously. This will take a long time to actually complete, but we've partnered up with Infineon, for example, to develop a chip, a physical little chip, that will store your seat on your car, on your IoT device, on wherever you want. It's supposed to be small, really cheap, because the IoT consists of really cheap small devices and small devices. And the seat that's stored on there is supposed to never leave the device, so it cannot be stolen. It's a bit like, I don't know if you know it, but there's This is why this picture is here. The trusted platform module is like the Pandora of that currently exists, but it doesn't support IOTA, so we want to make our own. Yeah, so that's what it is. Yeah, let's innovate together.
Any questions?
Does the chip need Does the chip need a backup absolute power supply, or is it radio powered?
What the chip?
Yeah, the chip.
The chip is implemented. Well, okay, so how the way TPM currently works is it's physically implemented on the hardware, right? So if you have some IoT sensor or whatever, the chip would be physically on there. So it uses whatever power supply you have on the device.
Okay, I'm asking because I'm thinking of what can I attach it to? Can I attach it to parts of the car, for example, not just to the car? Spare parts management, for example, battery management, stuff like that.
I would answer with this, but keep in mind this is a research project. This is ongoing work. We've applied for financing. This has to be. It will take. We are planning it for it to be 3 years of scope. So this is like the hardware side, the software side is already done. So until we can finally answer that, it will take some time, I guess. But we imagine it currently to be more or less like the TPM, which can basically apply to anything you want.
A basic question: what is a seed in IOTA? Is the private key, or is it something at a different level than a private key?
Well, you generate your private and public key keys out of that.
So you can create
so it's a
private key with one seed?
Yeah, it's basically a key, and you use that to generate an theoretically endless series of public and private key pairs.
But I could also create without the seed. So what is the purpose of the seed?
Pardon?
So I could create private keys without the seed.
No, you need the seed. You generate them based on your seed, deterministically.
So I can create the same private keys with one seed?
Yes.
Again and again, deterministically? Or?
Well, yeah, it's deterministically. So the first private and public key pair you will generate out of your seed will always be the same, and the second will always be the same but different than the first, and the third will always be the same but different than all of them before. Right?
I have a question related to the architecture of the identity of a vehicle. Is it like a vehicle has one identity, or like each part of the vehicle could have one? Like, you know what I mean? Like the headlamp has its own identity, and maybe the battery another. How does it do that? What's ideal?
This one, the vehicle, each car has one identity, which is unique and which is issued by the registration office, right? Sure, I mean, theoretically you can apply an identity to anything, right?
You're thinking about that.
Yeah, I mean, this goes into the digital twin kind of era, right? Where you have basically a digital counterpart for every physical thing you have in your, for example, car, and you can apply at least to each of those different parts, right? You have predictive maintenance or whatever you want.
One identity is one private key at the end.
Yes.
So if this chip can create n private keys, then it can actually also represent n identities. Do I understand right? Or?
The chip has a seed on it, right?
Yeah, which I can use to create more private keys.
So I could copy more key pairs, right? It's not. The chip is not meant to represent the brand. The chip is meant to be issuing payments, for example.
And signing the transactions.
It's on the transaction form. Yeah, sure, yes, exactly. Without exposing the seed.
Why would you need a specific chip for it? Why is it not integrated within SoC, like a standard automotive chip that has one sub-feature for security aspects?
It's the same argument for using a TPM in the first place, right? It's another barrier for security. And you don't expose your seed ever. So which might not be guaranteed if you just store it alone. like expired on the device or
No,
whatever.
but no, if you have a secure hardware inside the same package or the same chip, that it could be one sub-function of a bigger chip.
Oh yeah, sure.
Yeah.
Yeah, sure. This is meant to be really cheap for IT devices. So
adding another chip has some cost. Adding some silicon inside an existing chip is maybe cheaper. And also, automotive chips already have security features like this to authenticate the binary that they run, for example. So it looks like it's something quite similar. So maybe there are some features that you can use, or
yeah, maybe.
yeah, I don't know. I'm just trying to understand this because I know the security of the binary that you run on these things, but yeah, I'm trying to just see the differences.
We are planning to have this be trinary though, but the thing is that we are also working together with Infineon, and Infineon is not planning to have it trinary. So we need to put the stuff up on this.
Okay.
You said that you register the identity on the tangle, and then you can verify later on that this is a registered identity or not. Yes. So you are.
Yeah. So basically, the tangle has a copy of that in the card.
Yes. So you're using Tangle for kind of messaging system, but we know that.
Yeah, which means that you need some kind of terminal if you're referring to. Yeah.
Yes. And actually, I was thinking, how is the progress with soft tangles that they could work like side channels? Could it be a solution that, because if you just start using Tangle as a messaging system and register your messages there,